Okay, so today's lesson is on nonlinear systems. You do have a ditto to do for homework, so make sure that gets done and submitted to Google Classroom. Okay, so first of all, nonlinear systems of equations. What do I actually mean by that? Well, two or more equations because that's what makes a system, right? If you have two or more equations in which at least one of the equations is not linear, meaning not a straight line. Okay? So, the solution set to a system of equations is the set of points in which these equations are true or where they cross each other. Okay? So the solution set to a system of equations is the set of points in which the equations are true, and what you're looking for is where they cross. There can be one solution, multiple solutions, or no solution at all. All right? So if you need a second to fill in the notes, pause the video. But underneath here, you see your three potential things that could happen. All right? You could have only one solution, so where the two graphs touch each other one time and one time only. You could have multiple solutions. So like here, we have a line and a parabola. They touch in two different spots. Here we have two parabolas, again, touch in two different spots. Or you could have no solution at all. So when you look at this last one, we see this parabola, and there's this line underneath. It never even touches it. Or you see these two parabolas. They never even touch each other. That would be an example of no solution, because the graphs never cross each other. Okay, so we're going to take a look at a couple of different possibilities. So let's look at question number 1, and it's asking us to solve the system by graphing each equation. Well, in this first set here, in question number 1, this is an example of a linear quadratic system. Because if you notice here, we have our equation y equals 2x, negative 2x minus 1. That is a linear function because it has a highest exponent of x to the first. Whereas our other equation, y equals x squared minus 6x plus 3, that is a quadratic function because its highest exponent is square, second power. Okay, so we're going to graph both of these, and we're going to utilize our calculator to help us. Okay, so first off, I just want to make these axes a little bit darker here. All right, so we can see them a little bit better. There's my y-axis. There's my x-axis. Always make sure you label your axes. So we have x and y. All right. Now the green equation, since it is linear, that's a little bit easier for me to handle. I just need to know my slope and my y-intercept in order to graph that. So remember, for linear functions, our slope is always the number that's in front of x. So here we have a slope of negative 2 because there's a negative 2 in front of my x. So my slope would be negative 2 or negative 2 over 1, whichever way you want to write it. And my y-intercept is the constant that follows, so my constant here is a negative 1, making my y-intercept a negative 1. Okay, so we're going to start our graph at a negative 1 on the y-axis, and then our slope of negative 2 tells us that we're going to move down to right 1. So I'm going to go over to my axes and start at a negative 1, and we're going to go down to right 1 until I run out of room. Okay, now I ran out of room in this direction, but I do have more room still in the other direction. So remember, you can always do the exact opposite. We'll go back to my y-intercept and now go up to left 1 until I run out of room. Okay, connect your dots as neatly as possible. Make sure you have arrows on both ends, indicating that the graph does go on forever, We just ran out of room. Also, make sure that we label, this was the equation, y equals negative 2x minus 1. Okay, so for linear equations, we just need our slope and y-intercept. Now, for my quadratic equations, we usually use our calculator to help us make a table of values. Now, remember, when you use your calculator and make this table of values, you want to look for that symmetry in your y column. Okay? So first off, let's see how big our axes are here. It looks like they're probably 10 by 10s, but let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the highest we can go is 10 in any direction. All right, so we're going to go to our calculator. We're going to go to y equals, clear anything out if there's anything in there, and we're going to type in our equation for our parabola. So it's going to be x squared minus 6x plus 3. We want our table, so we're going to hit second graph. Now remember, it's the y column you want to pay attention to. The x's, they're just going to go in number order. The y's, the blue numbers, are what we're looking at. We want to see the pattern of symmetry in that y column. So we want the y up top here to match the y down at the bottom. Right now they don't. We have a 3 at the top, we have a 43 at the bottom. Not the same. Now 43 is pretty big, so I'm going to start moving in the other direction, searching for that symmetry, and I didn't have to go far. We have a 19 up top, we have a 19 down at the bottom. Okay? And as you look in that blue column, you'll notice that symmetrical pattern. 19, 10, 3, negative 2, negative 5. We hit this negative 6 in the middle, and then the pattern repeats backwards. Negative 5, negative 2, 3, 10, 19. Okay, you want to see that symmetry. If you don't see that symmetry in your table, then you're not going to see the full picture of your parabola when you go to graph it. Okay, now some of these numbers are too big, right? 19 is not going to fit on our graph paper. So I'm only going to start with the negative 110 and go down to the 710. All right, so we're going to go from negative 1 to positive 7 because the y's that go with it, those are the ones that will fit on my graph paper. So I'm going to go from negative 1 to 7. So we have negative 1. All right, let me check. Okay, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. And now we're going to put the points that go with it. So we had 10, 3, negative 2, 10, 3, negative 2, negative 5, negative 6, and then the pattern repeats backwards. Negative 5, negative 2, 3, and 10. Okay, so now here are the points that we can go ahead and plot, and you'll see it'll form our parabola for us. All right, so we have negative 1, 10, 0, 3, 1, negative 2, 2, negative 5, 1, 2, 3, 4. Oh, I'm going to off on that one. 2, negative 5. So 1, 2, 3, 4, 5 right there. And now see how I land on the green graph? That's okay. Then we have 3, negative 6. Then 4, negative 5. 5, negative 2. 6, positive 3. 7, positive 10. Connect our dots, again, as neatly as possible. I have a little trouble with this sometimes. Arrows on the end, showing the graph goes forever. Don't forget to label. Y equals x squared minus 6x plus 3. Okay. Now you can see that our blue graph hits our green graph in one spot, right there. Okay? You noticed that as we were plotting it, that I plotted that blue dot right on top of my green line. So all we have to do is state the coordinates of that point. And if you look at that point circled in the purple, that is the point 2, -5. So that would be my solution. And this particular set of graphs would only have one solution because they only touched each other one time. These other two blue dots came kind of close, but they weren't exactly on the line. They're just a little bit off. All right, you want them to have the same exact point in common. They want to actually physically touch. Okay, so this is an example of a linear with a quadratic. All right, let's look at another one. Let's look at two quadratics put together. Okay, so let's take a look at question 4. Okay. So again, notice here, question 4, we have two different graphs. One is y equals -x² plus 4. The other is y equals x² minus 4x minus 2. Now, these both happen to be quadratics. They both have an x squared. Okay, this is another type of pairing. So since we have both being quadratics, we're just going to do two tables of values. All right, so we'll do one for the green graph, and we'll do one for our blue graph. Again, I want to make these axes a little darker for us here. So there's my y-axis, there's my x-axis. Okay, always make sure you label your axes. Okay, and now I'm going to get the calculator to help me. All right, now remember, check to see how much room you have. So again, we're dealing with 10 by 10 grids here. All right, so I'm not going to be able to plot any number that's bigger than 10 or smaller than -10. All right, so let's start with our green graph. We have -x² plus 4. All right, so I'm going to go to my y equals, clear it out, and type in -x² plus 4. Go to my table, second graph, and look for my symmetry in the y column. All right, right now I don't have it. I have a 0 at the top, a -60 at the bottom. So I'm going to go searching for my symmetry. There it is. We got -21 at the top, we've got -21 at the bottom. So there's my symmetrical pattern. But again, not all of those points are going to fit on our graph paper. -21 and -12, those are too far in the negative direction. We can't go past -10. So we are going to start with the point -3, -5, and I'm going to go down to the point +3, -5. All right, so my x's are going to go from -3 to +3 for this green graph. So I'm going to go -3, -2, -1, 0, 1, 2, 3. Okay, so we have -5, 0, 3, 4, -5, 0, 3, 4, and then the pattern repeats backwards. 3, 0, -5. So now I'm going to go over my graph and I'm going to plot those. So we got -3, -5, -2, 0, -1, 3, 0, 4, 1, 3, 2. Oh, we were supposed to be at -2, 0, and I did -2, -1. Let me fix that. I'm going to say something wasn't lining up there. All right, so it should have been -2, 0, so there. So then we have +2, 0, there we go. And then 3, -5. All right, so there's my parabola. We got our nice U shape. Connect the dots as neatly as you can. Don't forget your arrows on the end to indicate there's more points. And label. so there's our first parabola. Now we're going to do that all over again for our blue parabola. Okay, so now same process all over again. We're going to go to the calculator, go to y equals, clear it out. Now we're typing in our second parabola. So we have x squared minus 4x minus 2. We want our table, so we're going to hit second graph. And now we got to search for that symmetry in the y column. Right now I've got a 43 at the top and a 3 at the bottom. So I'm searching for that symmetry. Sometimes you have to scroll up, sometimes you have to scroll down. You just got to look for it. Now here's that symmetry, 19 at the top. I've also got 19 at the bottom. Okay? But again, some of these numbers are too big. I'm going to have to leave out that top point of negative 319 and that bottom point of 719. Those will not fit on my graph. So I'm going to start at negative 2 for my x's and go to positive 6. Those are the ones that will fit. So we're going to start at negative 2 and go to positive 6. So negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Make my table a little bit longer there. Okay, and now we're going to fill in our y values. So we have 10, 3, negative 2, negative 5, 10, 3, negative 2, negative 5. Then we had a negative 6, and then the pattern repeated backwards. Negative 5, negative 2, 3, 10. Okay, parabolas are always going to have that symmetrical pattern. So now we're going to plot all those points. So we have negative 2, 10, negative 1, 3, and notice I'm landing right on the green graph. 0, negative 2, 1, negative 5, 2, negative 6, 3, negative 5, and notice again I hit my green graph. That's okay. Then we've got 4, negative 2, 5, 3, and 6, 10. Okay, we connect our dots, again, as neatly as possible. Arrows on the ends. Label. And here, this time, our parabolas touch in 2 spots. There's one spot right there, and a second spot right there. So we are going to have 2 different points as our answers here. All we have to do is state the coordinates of those 2 points that were in common. So one of them was negative 1, 3. And the other one is 1, 2, 3, 1, 2, 3, 4, 5, 3, negative 5. So this particular system had 2 answers. There were 2 spots where the graphs crossed. Okay, remember, sometimes there's 1 spot, like the last question. Sometimes there's 2 spots, like this one. And sometimes they won't even touch each other at all. It depends on the system. Okay, so we did a linear and a quadratic. We did a quadratic and a quadratic. Let's look at another different one. Let's do a quadratic and an exponential. We haven't looked at an exponential yet. So let's look at question number 6. Okay, question 6. So here in this problem, we have y equals negative x squared minus 8x minus 7, another parabola. You can tell that by the x squared. And then we have y equals 18 times 1/3 to the x. This time that's an exponential function, and we can tell because we have a variable in the exponent position up in the corner. Okay, so for both of these, once again, we're going to make tables. All right, so the exponential one is slightly different than the quadratic one, but we're still going to make tables. All right, so we'll start with our green one. know what? I think I might need a little bit more room, so I'm just going to put it over here. Okay, and we'll need one for our blue graph as well. All right, we're going to have our x's and our y's. Let's darken in that axis again. Now notice they moved my x-axis on us, probably because we're going to have a lot of positive numbers and not so many negatives, so they're trying to help us out with space here. All right, and make sure you label x-axis, y-axis. Okay, so let's start with the quadratic. We just did 2 of those, okay, so we know what we're doing there. All right, so we're going to go to our y equals, clear it out, type in our new quadratic. So we have negative x squared minus 8x minus 7. Go to our table, second graph, and look for your symmetry. Here it is, negative 16 at the top, negative 16 at the bottom. Okay. Now, let's see, since they moved our axes on us, let's see how high we're able to go here. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We're able to go as high as 19. Okay. Well, negative 16 and negative 7, those are both in the negative direction, and we're not going to be able to fit those on this graph paper the way they have it drawn for us. So the highest we're going to be able to go is this point, negative 7, 0 here. All right, so we're going to start at negative 7, 0, and we're going to go to 0, negative 7. So my x's here are going to start at negative 7 and work to 0. So we're going to start at negative 7 and work to 0. All right, find our y's that go with it. So again, starting at negative 7, we have 0, 5, 8, 9, 0, 5, 8, 9, and then our pattern repeats backwards. 8, right, did I do that right? 0, 5, 8, 9, 8, 5, 0. Oh, I left out one. We could fit the negative 7, sorry, we should have started at negative 8. Let's redo that. Alright, so let's move my table up a little bit here. A little bit more room. X, Y. So, alright, we were able to go from negative 8 to 0, excuse me. So negative 8, negative 7, negative 6, negative 5, negative 4, 3, negative 2, negative 1, 0. Okay, and then we're going negative 7, 0, 5, 8, 9, negative 7, 0, 5, 8, 9, and then repeat the pattern backwards. 8, 5, 0, negative 7. There we go. So now we're going to go ahead and graph that parabola. So from my origin here, we have negative 8, negative 7. Oh, that's why I didn't put it on there before. Negative 8, negative 7, they didn't give us any room for the negatives. So we really don't need these 2 points, but that's okay if they're on our table. We're just not going to be able to graph them because they didn't give us any room to graph negative numbers. All right, so then I am going to start with the first one of negative 7, 0. So 1, 2, 3, 4, 5, 6, 7 zeros, maybe right there. Then negative 6, 1, 2, 3, 4, 5. Negative 5, 8, 5, 6, 7, 8. Negative 4, 9. Then we have negative 3, 8. Negative 2, 5. And negative 1, 0. So there's our parabola. Connect the dots neatly as possible. Don't forget your arrows on the end. Label. y equals negative x squared minus 8x minus 7. Okay, now we're going to do our exponential function. So this is the first one we're doing of these here with this system. Now, we're still going to use table of values, all right? But remember, with exponential functions, sometimes you get a lot of funky numbers in the table, so we usually just pick and choose the points that we want to use. We pick out the nice whole numbers, and if we have to, some decimals to be able to estimate. But the important thing is we need to have enough points to get that nice hook shape that we should have for exponential functions. All right, so we're going to go to the calculator, we're going to go to our y equals, clear it out, and put in our exponential function. So we have 18 times 1/3 raised to the x power. Okay? Now remember, notice I didn't use my fraction template that the calculators have here, because if I use my fraction template, then the calculator is going to put my answers in fraction form. In order to be able to get actual decimal values, I have to type my division in the way I did as a fraction, 1 divided by 3. I have to type that in as actual division, which is what fractions are. Okay, if I use the little template, it's going to make all my answers in fraction form. Okay, so now we're going to go to second graph. There's my table, and now those numbers are huge. Obviously, I'm not going to use those. I'm going to keep moving till I get to some more reasonable numbers. And remember, I believe we said our graph goes up to 8 to 19, right? So I see a 0, 18 here. That's going to be good. So let me at least go start with that. So 0, 18, I'll use that. 1, 6, 2, 2, those are all great. And then all the rest of these are crazy decimals. You see this? Now notice how some of them have this E popping up. That means that the calculator is starting to write these in scientific notation because the numbers are so small. It doesn't have the room to write out the number in its full decimal form. So it's shortening it and writing it in scientific notation. So that E stands for the times 10 to the that you see in scientific notation. So for instance, this 3e negative 4, that's really 3 times 10 to the negative 4th. So these numbers are incredibly small decimals. So we're going to move away from that. All right, and I'm just going to use the nice numbers that we saw. So I'm going to start with this 0, 18. I'm going to use those nice 3 whole numbers there, and let's see if we get our nice hook shape. So we have 0, 18, 1, 6, 2, 2. Let's start with that. So 0, 18. I'm pretty sure this goes up to 19, but let's just be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, 18 would be right there. Then we got 1, 6. Then we got 2, 2. Okay, now you can't quite see its hook shape left. I should start to flatten out down here. So I'm going to want to use a couple of decimals. All right, so let's use a few of these. So 3 and 0.6 repeating. So we got 3 and 0.6 repeating. Then we have 4 and 0.2 repeating. And then we got 5 and 0.0741. All right, so now 0.6 repeating. That's a little bit more than 1/2, 0.5, right? So we're going to go to 3, 1, 2, 3. Here's 1.5, will be somewhere in between. Then we get a little smaller, and a little smaller, and now you can see that hook shape. All right, so we connect as nicely as we can. Arrows on the ends, and label. And now notice our graphs do not hit each other at all here. They never touch at all. So this would be an example of there being no solution. So you could write your empty set, or you could write no solution. Okay, so there's one of each of the different things you could see. One where the graphs touch each other one time only, once where they touch the graphs touch each other twice, and ones where they don't touch each other at all. Okay, so that's it for this lesson, and I will see you next time.